Sorry, I just dropped in a script that's pretty bog standard. Just up to you guys if you want to follow it. I think Robin doesn't have electric, so
Okay. Yeah.
might just be me and you today, Kevin. Simon's too busy to turn up. Hello, everyone. I can see people joining in now. Please do say hello in the chat. I can see more people joining in. But okay, we'll wait till 5 past and then join in. We'll kick off. Just waiting for a few more people to come. We'll also be sharing the recording of this webinar. Okay. Amazing. Should we kick off? Amazing. So, can everybody see my screen right now? Yep. Okay. So this session is one of our first sessions, which is all about how do you actually dive under the hood of LLMs and start to understand them. And we are very excited to share this with you because what we've always wanted to do as a company is to give garment engineers, costing apparel technicians a very good and clear understanding of how AI works. So this will be available later as well for you to share with your community. Now, the session, I'm going to give a little bit of context around uh, this webinar, which is essentially the purpose of it is for you to feel confident when you're looking at outcomes from using ChatGPT or Claude afterwards as you're using it and feel that you have a good idea of where AI hallucinates, how you can overcome those hallucinations, etc. Kevin's going to talk us through some basics of prompting for costing engineers using open platforms like ChatGPT and Claude. I'll then give you an intro to Markdown files, And markdown files are a really good way to give LLMs your context and improve outcomes. We're then going to do, Simon will then join us for a little brief overview of how at Mani AI we are tackling the weaknesses of LLMs. And finally, Rabin will talk you through how we actually do training for enterprises as well. You can stop us anytime, ask us as many questions as you like, but that's really the purpose of it. So, um, yeah, it's a bit of a behind the scenes look. So, before we jump in, I wanted to ask how many of you have actually used LLMs for generating a tech pack or an operation breakdown? How many people have actually done that themselves? I'm waiting for the responses to come in. There don't seem to be a lot of yeses. So then I'm assuming that nobody has ever used an LLM for, okay, so Shobit is saying he has done it using ChatGPT. Not actually able to see right now how many attendees are live on the platform which we're on. Okay, so given that there's just one person who said yes, I will talk you through, Kevin will talk us through some basic prompting. And then maybe Shobit, you can share your experience as well. And then I'll explain markdown files, which is a way to improve those outcomes. So over to Kevin. Kevin, do you want to take us through the process of using your experience as as an industrial engineer who's worked at Burberry, who's worked at GST? Take us through an example of you using ChatGPT or Claude for your work.
Yeah, I've been using both ChatGPT and Claude. I actually prefer Claude. It gives a better visual outcome. But I run this. It's a very basic tech pack for a simple T-shirt, and I put this into Claude, and I basically just asked it, "Can you supply a bill of materials and an operation breakdown with standard minute values?" I did this. I've done this a couple of times, and it's interesting that I did it yesterday, and the outcome, it came back with something like 35 minutes. The actual outcome looked very nice. The tables and everything else was very good, which I think is on one of the next slides. Yeah. So the way that the result comes up, this is the bill of materials. It looks very good. I'm quite impressed with the way it's laid out. I'm not usually impressed with the actual numbers and the data. This is the standard minute values, and for a base value for a basic T-shirt at 30 minutes is probably at least 3 times too high of what it should be. So for me, instantly rings alarm bells, and I need to begin to look at the individual processes.
Just to pause you here, Kevin, and I'm going to just share a different tab to show folks who've never done this before. So what I did was use the exact same file which Kevin did, dropped it in, so dropped in this image, and I
Yeah.
just gave this prompt, which is convert this into a BOM, operation breakdown plus SMV. And it gave me this overview. And interestingly, even though I use the same prompt as Kevin and the same tech pack, the results which I'm seeing in terms of consumption, the units of consumption, um, the usage of the meat, the sewing thread, mine is at a cone level, Kevin's was at a meter level, the format, the timing, it's all very different, right? So this is kind of step one. And this is why, because LLMs are very different in their outcomes, we decided to take screenshots of one output. And that's what Kevin is going to talk you through.
Yeah, because on this particular one, as I said, it worked out at 30 minutes. I did one this morning, and it was actually half of that. It came out at 15 minutes. It's still not quite correct, but as I'm a very skilled industrial engineer and I've worked with GSD, I've actually used it for the past 40 years. I was one of the first people to be trained up. I can instantly see, for example, a joined shoulder seams on a 5-thread overlock. A standard minute there of 1.61. To me, that is a process that can range from 0.3 up to maybe 0.5, and certainly no more than that, depending on the machine, the method, and so forth. So what I was then interested in doing, so my next step was basically to go back to Claude and ask a direct question, which was, can you show me how you reached a standard minute value of 1.61 for overlock shoulders? It basically came back and told me, well, it hadn't actually calculated anything. It had found something on the internet that gave a garment industry standard of 1.4 for overlock shoulders, and that's what it has used.
So here in this case, where I've run it, Kevin, it's giving me, again, a different answer where it's saying the standard minute value is 0.55, which I'm guessing is closer to what you expected.
It's 0.5. Well, it's getting closer then, because the one I ran this morning, it actually came at 0.92.
Okay. So let me ask it the same question which you did. How did you come up with the standard minute value for the shoulder joining? And it's quite a different format it's given it to me in as well. And I guess this is something where you can control the format, and we can talk you through this as well in prompting. Here it's actually giving me a GSD MTM buildup, Kevin.
Yeah, that's interesting, because I was looking at that earlier as well, and some of that I don't quite agree with either.
So it knows there's something called GSD. It knows there's something called MTM. It knows there's something called TMUs, but you're not really agreeing with how it's doing it.
Because what it's saying there, for example, what does it say for the sewing? Yeah, sew left shoulder, 0.1. The sewing time, and this is through the GSD sewing formula, it's half of that, it's 0.05.
And so this, because you're so experienced, you can look at these numbers and actually figure out what's right and what's wrong. But even in this process where, while preparing for this webinar, I've requested you to run it, and you've kind of had different results every time.
Yeah, and it's actually interesting now that you've just run it again, how it's getting closer and closer to what it should be.
Yeah.
But then I guess the question is, at what point do you actually believe what it's actually telling you?
Well, the thing is, right, it looks like it's getting closer, but I can assure you this is just a coincidence. And
Yeah.
so just, you've seen these 3 points, these sample points of, okay, it started with 1.6 and then went to 0.89 and now it's doing 0.55. That's not exactly how training works. So I guess an inside view, and this is what we kind of wanted to do in this webinar, is to tell you, like, it's the data sets which are involved in LLM training, right? So when we see, if we see, I like to think of it as looking under the hood. Okay, I have some sort of a diagram here. So if we look under the hood of an LLM, it's not learning in real time. Okay, so the data sets which Claude is trained on were locked like a month ago or something. And that's the model which it's looking at. It's not really taking this live input that all these people in London are suddenly uploading the same tech packs and they're asking me, and then it doesn't work like that. So training data for an LLM is logged at a certain period. And that training data is basically a snapshot of um, knowledge which the company, depending on how they've acquired it, um, and how up to date the sources which they're using are, it depends on that. Google is different in the way, Grok especially, and you can turn on modes in ChatGPT as well, where you give it access to web discovery. So it'll look at latest web files, but it's definitely not incorporating what Kevin is doing. It doesn't know we're in the same company. We don't have the same account, but it doesn't know that what you're doing, and it's not getting influenced in real life. So just a side note on how it's working.
Yeah. So, yeah, it reaches at the point where I'm thinking that whatever I asked it, it didn't come back with an answer as to actual factual data. What I've been finding for myself using these LLMs, they're absolutely fantastic if I give it a task to do. So if I wanted to sort out some PDF files or extract data from them, it's brilliant. It can do it in like the blink of an eye. A job that me as an industrial engineer would probably take half a day to extract it and put it into an Excel file. It's brilliant at that. But when I'm asking it for this kind of data, I think it's surely lacking.
Yep. And so do you want to give us an overview of how you'd normally do this calculation?
Yeah, you see, this is the answer that it came back with me earlier. And it says feed under overlock foot and guide the stitch, 0.55 minutes, so over half a minute. I know full well that as a 14 centimeters this seam sewing, as I've just said, it's 0.05. It's like it's 10 times higher than what that should be.
Yeah.
I then pushed it further and asked, well, where did you get this data? Can you give me the source? And it then replied that, which source data is what I asked. These are my own estimates. Well, how's it going to estimate it? I'm not quite sure how. Because it's not from a time study on an actual line, it says. It's not pulled from a licensed GSD card. And it's not from any specific published data. And then it basically tells me if I want an accurate one, I've got to go out and do a time study.
Yeah.
It's basically telling me what I already know. It's kind of, It's a very strange answer at that one.
Yes. And so, I guess behind the scenes, and this is my experience. So, something which I use ChatGPT for a lot is to write reports and to explain, to our investors, or if it's a white paper, something which is a trend. And it is good at showing sources which might be newspaper articles, for example. but it's very biased towards certain things. And I don't quite understand why certain things rank much higher on it than others. I do feel personally it's going very much in the direction which Google went, where ultimately it's just about ranking through whoever's paid the maximum for search engine optimization, who's bought the most adverts, etc. So it's interesting seeing the answer which it gave, Kevin, because it demonstrates that there is a knowledge there of different things like GSD, like Maynard operation sequence technique. I didn't know what this was.
Yeah, that one is actually used in the engineering trade. It's used a lot by Jaguar Land Rover and Airbus.
That's really interesting. So it and then it's asking you. I see here at the bottom. Do you want me to give it a source confidence column? Which is again, now a lot of these models have started giving these questions at the end, which are called clickbait questions. So we're all familiar with clickbait online in terms of news articles. But then seeing these clickbait questions come up here, the whole point is again, just like any other software or social media, it's to keep you on there, right? So ChatGPT specifically has these like 3 or 4 clickbait questions which come up, and the whole point is for you to keep asking it, keep using the tokens. So in conclusion, I mean, I guess there's another example which we pulled out earlier, wasn't it, Kevin, which was about the steaming, the tunnel.
Yeah. Because on the final press or steaming, it's got there either with a steam iron or through a steam tunnel. Now, with the steam iron, it's going to take you a little while because we all know how difficult the job ironing can be. But if you put it through a steam tunnel, you're basically hanging it up on a rail and it's automated. It takes seconds. So, quite why they can have the same standard minute value as options for both jobs, I don't know.
Right. So that's, this is, I guess, what we're seeing is the biggest takeaway is there's the timing. There's also issues around the logic, sequence, etc., which come up in garments which are more complicated than t-shirts. But it is great how good it is at saying, shoulder seams, then rib neckline, then, left stitch, left sleeve, right sleeve. The logical aspect seems pretty good to me as a non-engineer for a
Yeah,
t-shirt.
it's actually got that spot on. Yes.
So
You may have put the labels in at different points, but everything is extremely good. Yeah.
and so that's something which is really, interesting, is how good it's getting at that kind of logical work. So the couple of things which we wanted to cover with you is Claude off the bat is going to be really good with this formatting. So if I show it to you in my interface here, you can see it to the side. Have this is formatted as a Excel file, and I think you can pretty much ask it to change it to how Kevin's format was, and then etc., right? And it would do it. So it's a really nice format. And so the next step, so if the first step which you learn is prompting, which is just asking it, can you do this? Can you convert a BOM and operation breakdown? Can you convert a tech back into a BOM and operation breakdown? The second step will be asking it to do it in a format which you want it to, and then it's going to get there. You can ask it for assumptions, but the big issue is going to be timing, right? Because these formats are all about timing. And so how do you typically do it, Kevin? How do you get confidence that you've got the right timing?
Yeah. Well, within our own factory, we would have our own actual standard minute database. And obviously, from experience, that we would be able to pick a garment that is similar. What we would normally do when there's a large type of different garments, we separate them into types, or at Burberry we used to call them families. So there was one family which would be one type of trench coat, a second family which would be, for example, a bomber coat. So we would separate them into different families, and each family would have its own basic template. And we would use that basic template which is full of already proven standard minutes, and then we check the new garment and add any additions. Any additions that we would need to have, we would either have to go and actually time it in the sample room, or imagine it being done, because if you use a predetermined motion time system, whether it's GSD or whichever, you can actually visualize the process and then create the standard minute for that. It all takes time. What I would actually like is some kind of AI that would instantly trawl through our own factory databases to all the different tech packs and just do it for me. That would be the best way.
So let's talk a little bit about that then. So that's where markdown files come in, actually. And so let me give you a quick intro to markdown files and how they work. So when it comes to costing, accuracy, consistency, and trust, it kind of matters more than speed, because this is where the income of the factory comes in. And the way to think about the way these engines are working, it's essentially auto completion. And we saw two different formats with two different people, and three different values coming out, from 30 minutes to 15 minutes for a t-shirt. And this is because of the way LLMs work. It's not the LLMs don't have intelligence. They have, well, some people might not agree with that statement, but that's how I feel about it. It's essentially a huge extension of auto-completion. And so when we think about autocomplete, if you've used Google at any point, you type in something, and I clicked this screenshot earlier. You type in something like who supplies Levi's, and then it starts to come up with the closest match questions which other people have asked in the past. And that's pretty much how LLMs work. They work in a huge scale, so 1,000,000 times the scale of predicting the most statistically plausible token. So what's the next thing which one should say? And they work at that token level. And that is why you will see variability. And variability is one of the biggest things which you will experience in LLMs, no matter what you're trying to do. So I'm going to share a little bit about how you can start to control that variability, and introduce you to something which is called a markdown file. So the big thing is that as a factory, when you want, if you want to go beyond this, and as Kevin said, like what he'd love to do as a factory is, if he was within a factory, he would say, can you troll through all of my tech packs? Can you troll through all of my previous operation breakdowns and give me a better outcome? And the short answer is you can start to use it in that way to do that. And you can do something which is called creating a markdown file. So what is a markdown file? A markdown file is essentially a structured way to write down all the things which you want the LLM to know. Okay. And so I've created one which I'm going to show you, so that I'm going to try to share a different screen. So I'm going to stop sharing, and I'm going to share my entire screen for a second. Okay. And open this. So this is a markdown file. So you can use TextEdit or any file, really, any system which you have, and start creating files like this. And this file essentially contains knowledge of how, from my previous, from a factory, about what are the standard times which they have experienced in sewing, collar and neck operations, crew neck operations, flat knitting. So you can create a file like this which says, this is your timing, but this is a format in which you have to give it to them. And you can even use LLMs to generate these markdown files. So you can go in and you can say, this is a example SMV. Can you convert it into a drop markdown file? Oh, you're still seeing that screen. You're not seeing this one. Okay, so this is the markdown file. Sorry, I've just realized you couldn't see it earlier. So this is a markdown file which shows in a format which is really easy for the LLM to pass through what has been this particular factory's experience of working on different styles and what is the timing. So you can create these markdown files, and then you can actually, so let's go back to Claude now, and let's try to give it, so it's created this reference for me. Let me read the Excel first. So this is how I created it. I put in an Excel and I said, can you create the markdown files? And it created this markdown file for me, right? So that's how you create it. Now, if we go to, let me go back to the chat window where I was talking to it previously and say, this is great. This is a great start, but I'm not too sure about the timing. Not too sure about the timing. Can you please use this markdown file which I'm attaching to come up with the same timing again? And then I pretty much just attach this file which contains all the context which I wanted to know about. So I've got a folder here somewhere that says Claude for webinars. I'm going to attach this markdown file. And then it's going to run through this. And this is temporarily giving it context. And then it's saying, okay, this is great. From your reference styles, and Kevin, I think this is what you wanted it to do. These are the closest reference styles.
Yeah.
So it's comparing the image with that, and it's starting to come up with something which is very close to what the examples which I gave it. And it's running this now. So does anyone have any questions on markdown files and how they work? Kevin, I think this is the first time I've shown it to you. I've been wanting to do it for a while, but you know, I guess we've kind of just jumped into this webinar. But did that make sense about how you can create a markdown file?
It did make sense, yeah.
And so this is how you can start to have personalization and context around it. So if you were a factory which made certain types of garments, you could start by creating just Excel files, putting them in folders, and then giving them as context, and then seeing how the outcome improves. The caveat here is still that the LLMs do not fully consider just markdown files. So what I mean by that is, if you start to even give it details, and this is what I'm explaining to you right now, give it your own source, and that's going to improve the outcome. So I'm just showing this to you while we're waiting for the better outcome. And it's telling me this now that it's done it, right? So let's look at the outcome it's given me. This data is very grounded. Here's what's changed. Shoulder ops is now 2 ops. It's not just one. This is the difference in timing. And now I have this, which is this benchmark, which is 6.63, 6.87. Now, I know that that 6.83 and 6.87 actually links to a line which is operating at 80 to 85% efficiency. And this is a line which produces 2,000 garments a day. So that's still the knowledge in my head, right? So I still have that context. And it's just taking those patterns which it saw in the data I gave it, and it's applying those in there. So this is how, if you want it to be personal to your experience and you're happy with your timings, this is how you can start to use it, right? So this is how you can do this. Now, the caveat with this again is, with careful prompting and these techniques, you can encourage an LLM to prioritize your data, but it still can't be forced to use that content. And so it still has access to patterns from its training data, and you cannot guarantee the SMV in every output. Okay, so it's still not fully controlled. And this is what Mani AI spends a lot of time working on. So the big thing which I'd like you to take away from this is the quality of output depends on prompt quality and structure, but the reliable, traceable source for every SMV is what's missing. And I'd hope that our CTO would join in, but he's a bit caught up in a project we're delivering right now. But this is, so I'll cover his section, but this is where Mani AI comes in. We have our own SMV database. We spend a lot of time, and this SMV database is a curated database where we're looking at the world best standard of sewing and what should be the target which a factory aims for. And that's our base database, which is available for any factory in the world to use. We also have worked on a feature which is around asking clarifying questions, where we know the weakness of the models and we enter in clarifying questions based on the tech pack which comes in. And we also constantly improve visual detection. So for example, the tech pack which we used here is very straightforward. We picked a tech pack which is 1 page. And we know in real life, you'll have tech packs which are 30 pages, and some of them are internally inconsistent. So by that, I mean, you'll have on 1 page a text written which says, blah, 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 top stitch. And then on the next page, you wouldn't have that. And this is where Mani AI comes in and asks these clarifying questions. So this is what makes us different. And right now we have our database, which has more than 11,000 elements, which are all grounded in sewing performance data, which is derived itself from MTM. And we constantly improve the visual detection. So this is what our job is to ensure that from tech pack you put it in, it's completely traceable, it's linked to a verified source. And when you go to our system, and I think last time in the webinar, we demoed this garment, which is, the biggest difference which you'll notice when you use our product is, you can put in lots of things, and then it fills out things for you. It asks you questions about things which it's not clear with. It just doesn't just make an assumption, because that assumption is likely to be wrong. It then surfaces for you where the features are, and then gives you a breakdown which it knows matches sewing performance data timings, and you can trust it. You can also talk to the AI within Mani AI and ask it more questions, and it's got guardrails. All of our consumption estimates are also fine-tuned, and I can show you this on the back end, how we do our calculations another time. but there's a lot of data behind our work. So I could see a question here. I think Ruhi's asking, are markdown files a feature of Mani AI? So the short answer is yes. You can have them, you can add them in here. So the way we've done it, if you're using Mani AI and you want to get the benefit of the sewing performance data, time standards, as well as start doing training on your own, within our basic pack, you have the option of dropping in these files, and you don't have to drop them in as markdown files. You just drop them in as Excel files, and ManEI converts them into a format which it can use, and surfaces them as markdown files for your factory, which improves the outcome for you, right? So we've built this in a more user-friendly way as well. You can add finishing methods, you can change your efficiency curves, you can add knowledge, machine setup. And all of this front end basically translates into you influencing the Mani AI model. Now, let's go into a little bit more detail, right? So, uh, you saw how LLMs, they have a fast output, but the source is unknown. With Mani AI, you can have a fast output and a verified source, and the SMV database is proprietary. Every value is traceable. What if we went a step further, right? And so I'm going to check with Robin if he's available to talk through this. So I want to talk to you about what if we went a step further and we wanted to not just have very traceable SMVs, but also be able to train it on a factory's automated way.
Thank you, Shruti. Hi everyone, I am Robin, enterprise training side of the Mani AI. Because of complex garments, the challenge goes well beyond what a generic dataset or a prompt guide can handle. So the core limitation of these for complex categories like outerwear, in case like quilted jackets, and also internal heavy jackets like windbreakers. So there simply are not enough examples in any generic dataset to fine-tune reliably. So here in our system, we trained the categories, complex categories like the quilted jackets and also windbreakers. When our system is very much beginner stage, like our system was trained before for t-shirts, polo shirts, like these types of basic items. So in the types of initial period, we run through the complex categories, and we are talking roughly slow 16 samples per category versus the 250 you would need for a stable model. So our solution is custom training on a client's own historical operations. So many AI learns the specific SMB operation sequence and authoring conventions that are unique to their factory, not a generic approximation or a generic categorization. This is an example from an outerwear manufacturer. You can see the custom operational taxonomy we built covering weld pockets, belts, and a specialized hem, any other stretchable hoods, detachable collars, internal hybrid pockets like internal weld pockets inside the weld pockets, hidden patch pockets, hidden pen pockets, and also like the covering placket outside the jeepers, any other hybrid types of placket that is covering the collar and collar tabs, that is like belt, and also like this the architecture behind the this is a three-tier system, a bespoke ETL pipeline that parses the client operations database,
So
a
I'll just
canonical.
jump in here, Robin. So just to say, just to reiterate what Robin is saying, is that when it comes to complex garments, there's a limit to the operations which we've experienced exist in our MTM database. Like the SPD work which we have, there's a limit. And so when clients like this client had more than maybe 30 years of experience in making these complex garments, and they wanted us to take their best in class timings and convert it into a database. And so we trained it on their historical operations. And the example of t-shirts, it's a very simple example, and the markdown files, creating those is very straightforward. But when we're talking about years and years of data which needs to be cleaned and then retagged and then understood, that's what we did. And Rabin led that work. And this chart which you see is the example of how all these operations were created and then made specific to them. And this is what Rabin was just talking about. Sorry to interrupt you, Rabin. Do you want to talk about this ETL pipeline again?
Yeah, yeah, sure. So we see drastical change like the industrial data sets that are very much unmanaged and also so much complicated, and we sort out these in a ETL pipeline like that will help the customers in a good way. Their data sets combining the multiple process in the same elements in the multiple way and also multiple methods. Hence, the SMB times comes for a single process multiple times in multiple styles. Also, they combined multiple process even through multiple machines or multi manual and machines mix up operations to combining, and the SMB times would comes very much higher or very much lower in some case, and that our system can merge together, and we created sorted out the unmanaged datas in a efficient way like the operational taxonomy, and also in a reduce the short hallucination of steps, and also the steps that are very much unmanaged. So
Yes.
the simply that does not exist in any of the self data sets. The architecture behind this is a three-tier system, and the garments technicians and a hybrid interfering engine that combines retrieval generation and human in the loop validation. As a
So,
result, the
exactly.
production grade 90 to 94% feature detection accuracy, 100% sequence accuracy, percent at element level within the threshold of live cost.
Exactly. And so this is, I guess, a great case study which we wanted to highlight as a team about how, when it comes to factories and large enterprises which have years and years of data, how we do that training to start to get in not just results here, as you're seeing in operation breakdowns, but also in automatically completing bombs. And the key thing is to get consistency amongst this, which is what we're working on. And that's what we guarantee, that it's not like a LLM which is not trained on garment data specifically. We are specifically for garments, and that's how you
Yeah,
can be sure about the outcome. And so that's it from us. We have 5 minutes for any questions. If anybody wants to cover any specific points, we're very happy to do that. Robin, me, and Kevin would love to answer your questions. They have to come in through LinkedIn to this platform, so it takes a bit of time. So we'll wait for this. Meanwhile, Kevin and Robin, do you want to say anything else as advice or your experiences about as costing engineers?
I would say the way that the many I have worked, and I have seen that the element level and the categorization level of any products, like the girls dresses, the jackets, the t-shirts, shorts and joggers. So it will convert the elements parts by parts, and also finding the approximate operations of each and every elements and every specialized features. So this is a great features for the industrial engineers in the manufacturing operations as well as the marketing team. So they can also fine tune the features for the costing purpose, like they need to reduce some cost for the competitive market to pick the orders. They can reduce the hidden features which are inside the garments, that is not so much needed by the consumers, so they can advise the end customers or the clients that we can reduce the price by reducing these features, and
Yep.
it will
So I can also see some questions
saves
come
you the
in.
cost. Yeah.
Thank you so much, Robin. And I can also see some questions come in from various people. So I'm just going to take it in the order in which they're coming in. So uh, Ruhi said, "Will you be giving a demo of Mani AI?" So we did do that last time. I can very quickly show you our interface again. Um, Let me go into this mode of you being able to see the screen. Uh, right. So the way our system works is, and we'll be doing a demo again on the 9th of April with woven shirts. That's the next session which we'll be running through. So the way our platform works is you get a library of all of the garments which you want to run through it or have previously run through it. You have templates at the bottom of the standard garments which we have available. You simply put in your tech pack, and then you answer certain questions about the garment. It has the ability to read lots of pages of tech packs, gives you a summary of how things are working, and then sorry, I can see, let me hide this. Okay, yeah, I was sorry, I was seeing an overlay. It then asks you questions. You then start seeing the detailed elements which are there. You see the chassis, and it creates a full operation breakdown. The operation breakdown, you can see it in various formats. You can see the element breakdown, which goes into details of every element and the correct timing, as well as the operations. And you can also go into the detailed bill of materials. We also have settings where you can change your overheads, your profits, your standard minute values, the timing, the labor rate, etc. So that's how our platform works. Happy to talk about it more as well. I'll take the next question now. So what about the quality of tech packs? If the tech packs are not clearly explained, how will the costing be accurate? Yeah, so definitely this is something which is a cause for concern. What we do have in Mani AI is we have these modules where we explain, where we show where there's missing calculations and measurements. We have our own size measurements charts. which we pull in for menswear, women's wear, children, boys and girls between 0 to 2, and then 2 to 6, and 6 to 16. So we've got these different charts which we use to guide the LLMs. But yes, the better the quality of the tech pack, the more details it'll have. But this is not really a limitation on Mani AI. It's more a limitation on what you'll see from a standard LLM, because we do have inference and we'll ask you questions in the clarifying question section about things which we're not clear about, or things which haven't been answered in the tech packs. Okay, then we've got another question from Sachin: how it calculates SMV for new operation. So this is a great question. So we have within the statistics which we were showing you. Let me show you. Okay, so let's go into something which is these ruffles, right? So for examples, the ruffles on this particular T-shirt are not a standard operation. So the way Mani AI deals with it is it looks at the measurement chart. So it's gonna, okay, actually they are standard in this case. We've made them standard now. But if there's a new operation, it turns up here as purple, and it highlights that we have 80% accuracy when there's a new operation which isn't in our database. And that operation is converted live into a time and motion study breakdown using the sewing performance data system. And we'll be sharing that system very soon as well, in a few weeks' time, about how that conversion happens. So every day we're doing more and we're learning more, but it basically calculates, it identifies this is a new operation, and it then creates a breakdown. Okay, somebody asked, what will the next webinar be about? It's going to be about woven shirts and how LLMs identify details within that. Some of the tech packs only have garment images without any explanation of seams and stitches. Again, to your question, if it's woven versus knit, Mani identifies this within the first section itself, and then it has assumptions about the type of stitches which it will apply, and you can override those if they're needed. Then there's Sachin Yol, who's saying, how does Mani AI do method analysis for operation? So Kevin and Robin help us with this, and they are experts in motion time studies, and we have our own sewing performance database, which we use to convert all operations into, and that's what you see when you see our standard SMV values and results. Okay, we're just at time. So I'm going to stop now to respect all of your times and days. But thank you so much for this. Really great questions, and please do give us feedback on your experience of this webinar. What else would you like us to cover? We are here to, become a company where you can come not just for buying our products, but also tell us what you need, what are the tools you need, because we are creating tools with some of the largest companies in the world, and some of the most, like manufacturers as small as 200 people. So we want to be the go-to hub for garment manufacturing, right? So get in touch with us, and thank you so much. Have a great day. Kevin, Robin, I don't know if you want to say something.
No, I just yeah.
Thank you.
Thank you. Goodbye.
It was a great session, and we would love to hear from the audience more
Yes,
regarding their problems, and by their problem we can improve ourselves more.
ex-
It will be beneficial for us and both our clients and audience, I think.
exactly. So let's speak again. Thank you. Bye.
Thank you.